Welcome to Pomodoro Joe for Sunday, February 19th, 2023. Today we're looking at LeetCode problem 103, Binary Tree Zigzag Level Order Traversal. This is a medium problem. Given the root of a binary tree, return the zigzag level order traversal of its nodes' values, i.e. from left to right, then right to left for the next level and alternating between. So this is saying you start at the root, and then you go, that would be left to right. Then your next level, you go right to left. So 29, and then left to right again, 15, 7. So 3, 29, 15, 7. Okay. We have, looks like, fewer than 2,000 nodes. Okay. Well, we'll put 25 minutes on the Pomodoro timer and get started. So, normally with a binary tree problem, my go-to solution will be a recursive function. However, there is an exception. The exception is when you're doing a level order traversal. So level order traversal just means you're traversing the tree one level at a time. So you start at level 0, which is the root, and then you go to level 1, which is the first level down, and then level 2, and so on and so forth. Now, when you're doing a level order traversal, it is much easier to do this using an iterative solution. So that's what we'll be doing today. All right, with that, we will get started. So we'll have our result, and it will be an empty array to start with. But before we do that, I think there's one early out we can do. So let's just do that right away. So if our root is not, or if we don't have a root, so if not root, we can just return the empty array. Okay, quick and easy win right there. Now what do we need for this one? Well, we'll need the result, and we will return our result at the end. What other pieces will we need? So for the iterative solution, we're going to keep track of what level we're on, and we'll need to keep track of what nodes are in that level. So I'll have a level, and we'll start it with the root node. What else do we need? Let's see. Well, we'll need to keep track of the nodes in the next level. That's how we'll traverse this tree. We'll go through every node in our current level, adding all of their children to our next level. So we'll have a next level. And that will be an empty list to start with. We will also need to keep track of our current result level. So these levels, level and next level, these are going to contain tree nodes. Our result, however, we just need the values in those nodes. So we'll keep track of a separate data structure that will be our result level, which is just the values of the nodes. And that will be an empty list. And the last piece that we'll need to know what level we're on, so we know if we're going from left to right or right to left. We could keep a level count. I think because we're alternating between left and right every time, I'm just going to keep Boolean. That's left to right, and we'll set it to true to start with. So those are the pieces that we need. Our current level of nodes, what's the next level of nodes, our current level of values in those nodes, and then if we're going left to right. Okay, now the actual tree traversal part. So while we still have some nodes in our current level, we'll need to process them. So that's while we have level. Now for each of these nodes, we'll just grab the first node and we'll process it. So node is equal to. We're going to pop the first node out of our level. This will be the leftmost node. In the very first node, it's just the root node. Next, we need to make sure that we have a node. Some of these nodes will be empty. There will be none. So first, we'll check if we have a node. And if we have a node, then we'll process it. The way we process the node is, this is our current level, so we'll grab its value and put it into our result level. Actually, I'm going to rename this level result. I think that's easier. So this is the result for this level. So we'll append this node's value to our level result. And we need to prepare the next level for processing by adding this node's left and right nodes to our next level. So there we add our node left and node right to our next level. Now I'm not doing anything with our left to right here. I'm just going to go through this in the straightforward level traversal manner, left to right every time. When we get down to actually adding our current level result to our result, that's where I'll do the flip. So this will set up our current level result, and it will set up our next level with tree nodes to process. Now we need to do any cleanup. Let's say this is the final node in this level. We might have the next level to process. So let's just double check. So if not level. So if this level is empty, but we have a next level, then we'll swap them. So essentially we're saying our level becomes our next level and we'll continue processing. And our next level will have to reset to be empty. So that takes care of any cleanup in terms of swapping each level. So essentially you're saying, go through this level, building up what our next level is going to be. When we get to the end of this level, just swap out our current level with this next level, and then reset the next level to be empty so we can start filling it with the next level. And we also need to do some cleanup on our actual level result here. So we've reached the end of a level. We'll need to add our level result to our overall result. But before we add our level result, we may need to reverse it. This is where our left to right variable will come in handy. So if we're going left to right, we don't do anything. But if we're not going left to right, so if we're not going left to right, well then we need to reverse this level result. And we can do that. We can do that just by saying : -1. So this is slicing our result by taking negative steps. So this is a simple way in Python to reverse a list. And the final piece we need here, I guess we have two pieces left to clean up. So we flipped our result if we need to. We've added it to our overall result. Now we need to flip our left to right. Because we've reached the end of this level, we're going to go the opposite direction next time. So that's going to equal not left to right. And we need to reset our level result because we've reached the end of this level. We need to set this back to an empty list for our next level. And that should do it. All right, let's give this a shot and see how we do. Okay, that passes. Let's go ahead and submit. Okay, and we pass. We do okay. We're kind of middle of the pack. We beat 52% for runtime and 48% for memory. So let's see if there's some things that we can do to clean this up a little bit and make it faster. So we have our one early out, which is good. What else can we do? Trying to find some good things that we can do to clean this up. Well, there's nothing super obvious in here. We could try doing things like, instead of this plus equals here, we can just do a straight up append. Let's try it. I'm not super confident that will help us. So we'll append our left and we will append our right. No, that's significantly worse. We beat only 18% for runtime. We do much better in memory though. We beat 94% for memory. All right, let's take that back to where we had. Well, one thing that would be nice is if we can avoid this reverse. Now, there are ways we can avoid this reverse by how we append things to our result. Okay, well, let's try this. I don't know if this is a great solution, but it's worth a shot. So instead of doing our reverse at the end, we can check every time if we're going left to right or right to left. So if left to right, we will just append as normal. However, if we're going right to left, we will want to push our value onto the front. So we can say, okay, and that will remove the need to do this reversal here. Let's see if that still works. Still works. Let's see if this gains us anything for our runtime. A little bit. So we beat 76% for runtime and 94% for memory. We're doing much better memory than we do on runtime. So we jumped about 20% by making that change. What else can we do here? I am struggling to find anything that we can do to optimize this. There must be things that we can do. I hate to say it, but I think the next best thing is to change some of these variable names. I know, it seems ridiculous, but it does work. All right, so level we'll just call L. And next level we'll call NL. Level result we'll call LR. And left to right I'll call LTR. And result, I guess we'll just call R. All right, that looks pretty slim. The only thing I can do is change node to N, so let's do that. All right, that is as slim as I can go. And we get crushed. We only beat 24%. Wow, that's significantly worse. One thing I can try is using the plus equals operator rather than append. It might not work with this one. Hey, look at that. We are now beating 91% for runtime and 94% for memory. Huge win. I was very, very doubtful after this disaster of 24%. Just changing it to using the plus equals operator made a huge difference. Okay, beating 91%. Not bad. I'm sure there's still 9% there that we could win, but I'm out of time, so I'll leave that last 10% up to you. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can try this one on your own. Again, this is LeetCode 103, Binary Tree Zigzag Level Order Traversal. Thanks for watching. Hope you can go out and write some better code.